Okay guys, we continue for lipid. This is part 2, will be the last part for this chapter and also for this course. Okay, so we look at sulfonification number. Okay, the previous lecture we already looked at the sulfonification reaction. Okay, meaning the fat we react with sodium hydroxide. Okay, meaning we hydrolyze using base hydrolyze. Okay, to form back the glycerol and also the fat. But for then we look at the sulfonification number. Okay, in this case it's used to identify fat or oil, and then the definition is the number of milligram of potassium hydroxide required to react or to sulfonify 1 gram of fat and oil. In this case, in the formula, okay, so they use potassium hydroxide. Okay, or actually in real experiment, we can use potassium hydroxide, but at the same time we also can use sodium hydroxide, no problem. Okay, this value is proportional to the relative molecular mass, or we call RMM, of the fat and oil. Okay, so we'll look at the equations. Okay, to calculate sulfonification number, okay, based on the definition, number of milligram, okay, mg, of potassium hydroxide required to hydrolyze 1 gram of fat. Okay, so we use this formula. Okay, actually you can use this formula, sulfonification number. Okay, so this one. Okay, so you use this equation, this formula. You just need to find the molecular weight of fat. Okay, and then you get the answer. Okay, how to get this formula? Okay, because the triglyceride, it contains a three fat, right? Okay, triglyceride mean this one, so it's maybe this fatty acid A, fatty acid B, fatty acid C. Okay, so it contains 3. That's why 3. 56. This atomic number for KOH. So if we times 3, so we get 168. Okay, 168. This is equivalent for 1 gram. Okay, for 1 gram. But for the definition, it defined in the milligram. Okay, that's why we need change gram to milligram, and then we get to this 168,000. Okay, so in exam, sometimes molecular weight already given, so you just use the molecular weight, or sometimes only give the structure, so you need count the number of carbon, number of oxygen, and hydrogen. Okay, get the molecular weight and use this formula. Okay, for example, like in this question, what is the sulfonification number? One of the fat has the RMM. First is A 302, B 866. Okay, so you just use the formula. Okay, and then you get this one for A and this one for B. Okay, for B. Easy, right? Okay, next we look at the addition iodine number. Okay, the number in this the addition of halogen reaction. Okay, defined as a number of gram. This one in the gram of iodine that can be dissolved by 100 gram of fat. Okay, 1 gram number of gram of iodine needed can be dissolved in 100 gram of fat. Okay, higher iodine number means the higher level of unsaturation of fatty acid, or TG, the presence of more C double bond C. Okay, this is a calculation involve the iodine number. For example, that glyceride trioleate, or GT, has a molecular weight 884 gram. So for the oleic acid, 18 I mean 18 carbon, 1 double bond. GT we react with 3 moles of iodine, as it has a 3 unit of C double bond C, right? Because oleic acid has a 1 double bond. Okay, so for the fat or the GT, it has it's a one double bond, one double bond, one double bond, and one double bond. Okay, that's why it has total three double bond. Okay, 3 unit of double bond. Okay, and then we calculate the iodine number. Okay, so I mean 3 unit of C double bond C, we times with 254. Okay, 254 can get this number. This for iodine number, atomic for the iodine number. We times 2 because iodine is a I2 mole. So we get 762 gram iodine. We react with 884 gram of GT. Okay, so we look at the definition. Definition is about 100 gram fat. Okay, so 100 gram fat. We use simple mathematics. So we get this answer. Okay, get this answer. Okay, next we look steroid. Okay, this is the core for the steroid. This is a backbone core for the steroid. Content of 4 ring A, B, C, D. Okay, this is a common structure. Okay, you can read, no problem. Okay, and then we have cis and trans based on the stereoisomers. Cis and trans. And this is trans, this is cis positions. Okay, and then this is and trans steroid. Okay, so this is trans and this is cis position. Okay, this is important for terpene. Okay, terpene composed of 5 carbon isopentyl, or we call isoprene, isoprene group, isolated from the essential oils of plants, percentage of fragment aroma and used as a flavorants, example anise oil, bay leaf. Okay, this table so some essential oil with source and major component. Okay, for example, if you look at this celery, oil of celery, this is a major component. Okay, major component. This we call beta selenin, and this is one type of terpene. Okay, why we can spot that this is one type of terpene. Okay, because it contains of 5 carbon. 5 carbon. If you look at this structure, it contains 5 plus 5 plus 5. So in this case, 15 carbon. Okay. If you look at this more simple, like this one, mycin. Okay, this one contain 1, 2, 3, 4, 5. Okay, this is isoprene unit 5, and this is 1, 2, 3, 4, 5. Okay, so if you look at the structure, it's a 5 plus 5. Okay, that's why we call this a terpene. Okay, so structure of a terpene, it contain isoprene unit. Okay, so this is isoprene unit. Okay, isoprene unit, if you draw, is something like this. Mean it contain in this head part and this tail part. Okay, so for example, like mycin. Okay, so this head part 1, 2, 3, 4, 5. Okay, this is one isoprene unit. Okay, if they ask you to cycle or to find, okay, so you need this 1, 2, 3, 4, 5. Okay, this head part, this tail part. Okay, so mean for myrcene is contain 2 isoprene unit. Okay, 2 isoprene unit. Okay, and then for selenin, okay, this the head part. Okay, 1, 2, 3, 4, 5. Okay, let's see if we take this one. Okay, and this is 1, 2, 3, 4, 5. Okay, this is 1, 2, 3, 4, 5. Okay, for selenin, it contain of 3 isoprene unit. Okay, if you look at the shape, is the same with this one, isoprene 1, 2, 3, 4, 5. So contain this like head is a tail. Okay, it's a head and it's a tail. Okay, and then for how to determine for the terpene, only involve for the carbon atom. Okay, not for the other atoms. Okay, so in this case, okay, see? Okay, and then for classification of terpene, I classify the number of carbon they contain in a group of 10. For example, like monoterpene has 10 carbon, so contain 2 isoprene unit. So the class is a monoterpene. Okay, for sesquiterpene, it contain 15 carbon, so 3 isoprene unit. So we call it sesquiterpene. For diterpene is a 20 carbon, it's a 4 isoprene unit. It's a diterpene. If a 30 carbon is a triterpene. Okay, so if in a question they ask you to give the class, so based on the number of carbon you can detect, so you can use this information. Okay, so lastly, if the terpene contain oxygen, okay, for example like cholesterol. Okay, cholesterol is one part of a terpene. So we call terpenol. Terpenol means terpene that contain oxygen. Okay, uh, but it also contain of isoprene unit. Okay, for example like this one, 1, 2, 3, 4, 5. This is one isoprene unit. So you can count how many carbon that it has, and then you divide with 5. And it show you how many isoprene unit in the structure. Okay, so I think that's all. So thank you.